We got some kind of different notation here. We haven't seen this before, but really all it means is that you're taking whatever term you're using and you're using the value of the previous term is what you're doing. So I'll show you. Write the first 6 terms of the sequence. Well, just to kind of make it a little bit clearer to see, just kind of make yourself a little table. This is A1, A2, A3, A4, A5, A6. I don't know if that'll help or not, but it might help. Did they give us A1? What is the first term? So I'm going to stick it in here, right? Okay, A1 is -2. They gave that to me already. So then I have to figure out the next term. So just watch. If I have to figure out A sub 2, if I have to figure out, please pay attention to this one thing right here. If you can get it, then you're going to be fine with this. If I have to figure out A sub 2, that means I'm taking 2 and plugging it in for n there, right? See what I did? Well, what does this mean then? This becomes 2 minus 1, which is just the number 1, which is the value of A sub 1. See it? So this actually becomes, my A sub 2 is actually going to be this value, -2 plus 3. Okay? I'll do another one. So what is A sub 2 equal to? -2 plus 3, which is what? 1. Okay? And pretty soon you won't even have to write it all out. You'll just see it, but let's do the next one. So I have to find A sub 3, which means what I'm doing, my n is 3, correct? So 3 minus 1 is 2. So this actually becomes A sub 2, whatever that is, which is 1, plus 3. Do you want me to write it out, or can you see it? Pardon me? So A sub 3 actually becomes A sub 2 plus 3. And what is A sub 2? 1. So 1 plus 3 will give me that one. Let's talk about another one. A sub 4 is actually equal to A sub 3 plus 3. Correct? So what is that? A sub 3 is 4. 4 plus 3 is what? So really all you're doing is adding 3 to the previous term, correct? So what would this one be? What would this one be? And that's it. So it was really just kind of getting what the notation is, and then it's rather quite simple, that part. Okay? All right, let's do another one. Let's make the table. If it helps, you don't necessarily have to make a table, but it might help keep it clearer. So A sub 1 is what? 32. They gave it to us. And what this is saying is, to find the next term, you take half of the previous term. So do you all see that? Let me say it again. To find the next term, which would be A sub 2, I'm going to take half of the previous term. Yes? You got it? Okay. So what would this A sub 2 be then? A sub 3. Okay? It's just thinking about what the previous term is and then doing whatever the function says to do. Okay? So that's the first part. All right, recursive equations for arithmetic and geometric sequences. Really, it's just another set of, I don't know, is that even on there? Yeah, it's on your formula sheet. So all you need to do to write it if you're doing this is you need to know D in order to write the function. And for geometric, again, you need to know R to write the function. All right, write a recursive rule for the sequence and then tell us what it is. They didn't tell us if it's arithmetic or geometric. Sometimes it's easier to maybe look here. Can you see what's happening to the numerator? What's happening to the numerator? From here to here, what's happening to the numerator? By what? 2. What's happening to the denominator? By what? 5, correct? Numerator is being multiplied by 2. Can you see that? And the denominator is being multiplied by 5. Does that work for the previous ones if I go before it? How about 16 over 1 to there? If I multiply 16 times 2, I get 32. And if I multiply 1 times 5, I get 5, right? So maybe I'm multiplying each time by 2/5. Then what you can do, if you're not sure, you could do 40 divided by 100 on your calculator. And you could do 16 divided by 40 on your calculator and see if you get 2/5. How you feel about that? It works. R is 2/5, which tells me it's a geometric sequence. It's being multiplied by something every time. So then I've got to use the geometric one. So A of n equals 2/5 times A of n minus 1. And that's all you do. You plug in R, and you've got the rule. So then this one, let's take a look at what's happening here. Can you see it? You're just adding 20, which means it's what kind of sequence? Plus 20, plus 20, plus 20, all the way across. So it's arithmetic, and D is equal to 20. So then I can just write my function. A of n equals A of n minus 1, meaning the previous term, plus 20. Oh no. Okay. This is where you really have to open up your mind when we turn this over. It's not hard, but you just got to think a little bit. All right. Write a recursive rule for the sequence. I think these are going to be like the hardest ones that you might get. So it's not too bad. So have to think, how could I get a particular term by looking at the preceding terms? So sometimes I dive right in, like third or fourth one in, and say, okay, let's say, I'm just going to make a list here and see if this helps me. I'm going to write it like this. A of 2, A of 3 equals 18. Let's just work with those three. Is there any way that you can see of getting, say, the third term from the previous term or the previous two terms? Take a look at it. This one took me a little while, but if you look at it, how could I get 18 from negative 10 and 8 maybe? Do you have any ideas? Pardon me? Yeah, let's try using both of them, because it's not going to work just to use one. I can't just add 10. That doesn't work because it doesn't work from here. So maybe if I use the two previous ones. Vanessa, is that what you were going to say? Okay. Yeah, you can kind of see, well, I have a 10 and an 8 and an 18 here, but I need this to be positive, so I need to maybe do 8 minus 10, negative 10. So let's just, this is trial and error, so let's write this out. Okay, I can see this. I can see that. Let's see where this takes me. Maybe if I substitute in what the term thing is, it's A2 minus A1. Maybe this will help me get to where I need to go. Okay, I see that this is 3 and this is 2, right? So if I were to substitute in n, how could I represent this using n? Minus, how could I represent this using the n? And that's your function. So there's not always going to be a formula you have to use. You have to first come up with, well, how am I getting each of these, and then maybe substituting in and seeing where I'm going. And this is, like I said, kind of like 12.1. It's kind of like trial and error. And this is probably one of the harder ones you might see. But it's doable. You can do it. It's like a puzzle. Okay? Let's try another one. All right. Let's look at this one. Let's look maybe the third one in. let's just look, can I get the third one from the previous one? You see what might have happened to go from here to here? Yeah, I heard it. What did somebody say? Maybe multiply by what? 1/3. And then maybe from here to here, what would I maybe multiply go from here to here? 4th. Let's just start writing this down. A of 2. I'm going to start with A of 2. Don't ever start with the first one. Start with A of 2. I could get that by maybe doing this. What's 1 times 1/2? That gives me 1/2, doesn't it? Okay, how about this next one? I could get 1/6 by doing 1/2 times 1/3, correct? That gives me A of 3. You see that? Okay, let's try the fourth one then. How could I get the fourth one? I could do 1/6 times 1/24. Oh, excuse me. I'm sorry. Times 1/4. So let's just stop and talk about that. I can get the current term, like for example, A of 2 is 1/2, by multiplying by the previous term. Number. Let's say if I write it out, if I can get the current term by multiplying by, take a look. What do you notice here? A sub 2 and I'm multiplying by 1/2. A sub 3 and I'm multiplying by 1/3. A sub 4 and I'm multiplying by 1/4. So by multiplying by 1 over n, I can get the current term by multiplying the previous term, I should say, previous term, by 1 over n. I can get the current term by multiplying the previous term by 1 over n. Again, you just got to play with it a little bit. So let's put this into words. So that means A of n equals, I'm going to multiply the previous term, A of n minus 1, times 1 over n. These are like trial and error, kind of like 12.1. How did I get it? I kind of just started writing down. I saw that the second term, 1/2, is equal to the previous term, 1 times 1/2, right? And then the third term, 1/6, is equal to 1/2 times 1/3. And then the fourth term was equal to the previous term, 1/6, times 1/4. And then I noticed, wait a minute, A sub 2, 2, A sub 3, 3, A sub 4, 4. That is n, isn't it? So I can get the current term by multiplying the previous term by 1 over n. So then I put it into the function. There's nothing easy about it. You just have to play with it a bit. Okay. Not always. This one was not geometric. You have to just figure it out. Yep. Okay? All right. Let's keep going. These aren't bad. These are pretty quick. This is going to be the most challenging, but you can do it because you're smart. You can do it. A mosquito population in a controlled laboratory condition is estimated to be about 500. Oh, fun. Can you imagine? 500 mosquitoes. Each day, an additional 100 mosquitoes are hatched. Even better. Okay, the population also declines by 85% every day. If it declines by 85%, how much is left? 15% is left. From a pesticide. So they're killing those buggers with a pesticide, but there's still 15% left. And other natural causes. Write a recursive rule for the number A of n of mosquitoes at the start of the nth day. Find the number of mosquitoes after the 5th day. Describe what happens to the number of mosquitoes over time. Okay, what I know is A of 1 is 500. The other thing I know is that they're adding 100 every day, but the population also decreases by 85%. So I'm going to say A of n equals, it's actually easier than you think. I have 15% left of the previous term each day. But then we also have to add 100. That's it. Because think about it, if you start with 500, the next day you're only going to have 15% left of that 500, right? Plus an additional 100. And the next day you're going to have whatever that number is, you're only going to have 15% left of that, plus an additional 100. Okay? And then, this is how you figure out the numbers. So it's really tricky. It's really cool. Just go to your calculator. You got a calculator in front of you? Put 500 in. It's easy. Push enter. And then you're going to multiply by 15.15 plus 100. And then push enter. So on the second day, how many mosquitoes will there be? On the third day, push enter again. How many mosquitoes will there be? So let's write this down because we're not quite done with this problem. So A sub 2, we're going to have 175. That's day 2. Day 3 would be A sub 3, which would be 126.25. Yeah, we're going to talk about that. A sub 4, 118.94. A sub 5, 117.84. And then if you just keep going, like what happens to the numbers? They kind of do what? They stay at about 117 or 118 because you can't really have a partial mosquito. So we would probably round it. We would have to say, over time, there's going to be, the number of mosquitoes per day is going to be about 18. Per day is approximately 118. What, this? Okay, this is how you do it. You type in 500, I meant to write it down for you, and push enter. Type 500, push enter, and then you do your answer times 0.15 plus 100, and then just push enter. 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 Keep going. That's how you do it. It's just doing that same function every time. Okay? All right, iterates. Iterates are pretty easy. Nope. The first 3 iterates, x sub 1, x sub 2, and x sub 3 of this function for an initial value of x sub 0 equals 1. It just means the very first thing they did, it was equal to 1. So all you do is you plug in the previous terms. So for the first one, I want to find x sub 1 is going to equal my function with the value of x sub 0 plugged in. That's what that means. So you're going to plug in 1 because they told me that's what it was. So it's just this. X sub 1 equals 5 times 1, oops, minus 3. 5 times 1 minus 3. So x sub 1 equals 2. Okay, and then x sub 2, I'm going to plug in the previous value. So I'm going to plug in f of x sub 1. This is how you're going to see it written. That tells me to plug in 2, because I know the value of x sub 1 is 2. So x sub 2 is going to be 5 times 2 minus 3. X sub 2 is going to be 7. X sub 1, x sub 2. And then x sub 3, you just plug in whatever you got for x sub 2. So you're going to plug in 7. It's 35 minus 3. X sub 3 is 32. That's not too bad. Iterations. Okay? Oh, look, I typed the homework for you. The practice. Yes. Oh, jeez, oh, Peter.